Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about why EV adoption has failed so far in 2020. Let this be very clear, I do expect EV to take over, but why it has not happened so far yet. This is the point of this video. So what was the dream? So dream was very simple. EV is much simpler compared to thousands of parts. You could be looking at least 800 to 2000 parts just in the engine block, by the way, versus one part, rotor itself. So it is fundamentally much simpler. What does that mean? It has KISS, keep it simple silly. So it will supposed to lead to higher reliability. That's awesome. People like that. People do not like the idea of changing oil or replacing brake fluids and all that jazz. We do not like that. So that's a good thing. Then running would be cheaper than fuel itself, because again, oil is far more expensive compared to electricity. A unit of electricity is far cheaper than 1 liter of fuel, so to say. So if you can travel quite a long distance in a few units of power, you're gonna have a very cheap mode of transport. So that was the desire. And there were two external things that were happening while this was being built 20 years ago. Fuel prices were going lol, OMG, WTF. So fuel prices are like scary right now, like genuinely scary. Like we do not even have to compare it to like 1990 fuel prices. Like compare it to literally 2000 fuel prices, like damn. Compare it to 2010, still damn, it's growing exponentially. So that's painful. So this fact that it will be cheaper than fuel should have given an advantage where EV would have been like, shut up, take money. Another was degradation of environment, and at this point in time global warming has reached a stage where it's undeniable and almost everybody is feeling its effect. So people are far more cautious. So all these two things combined, all these dreams and this reality combined, should have created a scenario where EV was like, the moment EV could have been adopted, it should have been adopted, but that did not happen. Why? Let's dive deep into it. So there were certain lies that were told. Now let this be very clear. Never build a foundation of something based on lie. It will never last, even if it's a gray lie. Now what happens? The EV is cheap. Short answer, no. So cost sensitive market, this idea that EV is cheaper, no. More than enough Indians have suffered severely, including Europeans and Americans, where they are like, you have to drive a lot. Like for example, let's say a car is X price. A EV car would be X plus some percentage, some extra percentage. You have to drive a lot before you can save up that some percentage. And be mindful, the Mark 1 EV cars were ludicrously expensive or ludicrously cut down in terms of basically its comfort and its ride quality and all that jazz, or range. So fundamentally, you had to drive a lot before you were like, okay, you know what, if I have driven this much in a fuel car, this actually pays off way too much, like bonkersly large amount of it. And another aspect is combustion car, especially 90s car, they are very well built equipments and they last a long time, meaning you could literally, many people literally learns their driving on second hand car, third hand car, fourth hand cars are still a thing. And that does not happen with EV. Once you are using the EV, once the battery decays beyond a certain point, let's say it could be as low as 80%, because again, the oomph requirement is so high on a motor system, where it's like, even though capacity wise it has that, it just does not have the power needed for it. The car's computer would be like, bro, I'm out. So there is no ROI, so you could not sell it. And because of the anti-right to repair act that every company is just like salivating over and putting so much BS into their equipment, you cannot salvage a EV car even if you tried. More than enough people have tried, especially with Tesla. It's like, damn, it's bad. So fundamentally speaking, more than enough people have learned the hard way that is flat out not cheap. Even with two-wheelers, it's not cheap. Another aspect, EV is better for environment. That line should have never been spoken. That line fundamentally assumes future, does not assume true today. So example it this way. Right now, if you buy a solar panel, is it good for the environment? If you compare the energy requirement to make that solar panel, nowadays solar panels are so efficient, it can be made in 2.5 years. Basically, all the energy that it makes in 2.5 years period of time, average, it should be enough to like, it offsets the chemical, basically CO2 footprint of its own self. Now, after that, let's say solar panels can give you a lifespan of 25 years. So let's say that 20 years is running in carbon neutral scenario, or negative, if you want to be like that. So it's a very positive scenario. Now, is that true with the first generations of solar panel? Hell no. Is it true? Because the earliest solar panel that we had was 1% efficient. And be mindful, the silicon development happened because of two front attack. One front was solar energy itself. Second was electronics. We refined a lot of electronic silicon ingot refining process that trickled down into solar industry. That allowed more better improvement. So both of these allowed normal today solar panel happen. But here's still, if imagine somebody made this claim in the Mark 1 of solar panel, it would have been like tossed out of the industry. Thankfully, we had satellites that needed it, so that's why it worked. And EV literally fell into the same trap. It's like EV you are building today is not going to be efficient. It's not going to be carbon neutral. It's going to be bad. It's going to be brutal. But we are doing so because in tomorrow we are expecting that by tomorrow, by after let's say 20 years, after 30 years of experience, research, refinement, all that, then we're going to have a vehicle that would be very efficient. Now, is it natural for humans to do something like this? Yes. Even in India jumped headfirst into railway. And in our railway structure, we invested a lot. A growing country invested a lot in electrification of railway. India has like ludicrously highly electrified railway network. Like for our country's supposed standard of globally, we have very advanced electrical system. Why? India very early on, as in like as early as 1980s, figured it out that we do not have enough oil security, whereas like we can trust on diesel. And because railway is so important for India, it's like, yeah, we should invest into making it more immune, even though track cost per kilometer is exponentially higher than the diesel system. So we invested in it. And now, because we have so much solar energy, railway's footprint is slowly, gradually going down. Once we have more wind, once we have more energy storage and more transition to renewable happens, over time it will automatically become bigger. So we laid a good foundation, and that allowed it to become richer in future. That's how it works. That's how it's supposed to work. So electric, if everybody is like, we know for a fact, if the flat out statement was like, we know for a fact, we do not know how to make a good basically carbon neutral battery pack. Why? We haven't been building it. There was no scenario where people were like, okay, I want a battery pack that is light and robust enough that can handle crashes and not catch on fire. And it has to have enough oomph where it can be measured in kilowatts or pulses of megawatts. And it should give you like, a range of 300 kilometers. Like there was no scenario like that in 1990s. So how the heck you expect to build that without having a hell lot of chemical side effects? Which again, people are now finding out, oh, you're telling me that nickel and cobalt has a side effect? Obviously. So this lie that was like, it's good for environment, it would become good for environment. Not on day one, over time. If that lie was not spread, like a lot of people are so jaded about electric cars, like, this idea, like, oh, I feel so dirty and compared to like, it's just running on coal. That's the reason. Like, and again, early generation, especially Mark 1 cars, if you have compared their footprint, yeah, you had to drive them until every single bolt turned to dust. Only then you may be able to have a carbon footprint comparable to a normal diesel. Like, why is so low? We have been making this puppy for 1 century. Every kilowatt of energy that goes into a factory, somebody has already worked their ass off to optimize it. So the energy requirement for making a diesel car or a petrol car is exponentially lower. In battery, we do not know. In electric system, we do not know. So this whole idea, it's something that we were investing in the future. Instead of that, like, it's almost like somebody tricked you into investing into, let's say, a mutual fund, and then they're selling, oh, this is like, cheat fund. It's supposed to multiply every 2 years. Like, no, you're supposed to place it, wait for it. So that caused a serious rift amongst people. And that's why people are like, oh, I thought this, once they buy the car, they expect it to have the same polish as 1 century of R&D that fuel cars had. Like, yeah, that's not going to happen. Fuel cars were notorious for catching on fire. They were going booms. Not even joking. There are actual scenarios where some models are so bad that if you hit them from the back, it will go boom. Not even joking. Actually happened. But again, we spent time, R&D, lot of it. Only then now we have a car that is safe enough. Same will happen with electric, but not in first year, not in first generation. Right now, if it catches on fire, nobody has any idea other than to like just yeet it into a swimming pool, if you have swimming pool nearby, or just bury it in sand. So that lies had an effect. Now this is very clear. This is Mark 1, but this has to happen. This has to happen. This is laying a foundation technology. You laid a better foundation, then tomorrow you're like, hey, assume, let's be magical. Assume in 1 century we figured out fusion. No problem. This is done. Sorted. We built the same way. India. Let's assume India becomes at current rate, we will become very seriously dependent on solar. And we're going to be like, hey, our railways carbon footprint is going down exponentially. Why? We already invested into making it electric. So it's the same point. Sometimes you are investing in the future. You have to be honest about it. If you are not, it causes issue. And many times you must have seen people are very jaded about it. Oh, it's just burning coal, or it's that's the reason. You're not supposed to say that for Mark 1 product. So that lie caused an issue. Cheap part, brutal lie, people learned it the hard way, and oh, it does not require maintenance. Minor maintenance it does require will cost you arm and a leg. So yeah, no. So all of those things created a very bad taste in people's mouth. Now come to the hassle part. Now here's the deal. Right now, you can look into your charger. Whatever charger, Samsung, Apple, go YOLO on it. You never ever worry about where you are plugging it in. You never have to worry about it. If you can plug it into a country that is 50 hertz, it does not give a damn. You can plug it in America, which is 60 hertz, it does not give a damn. You can plug it in Europe that has 220 volt, it does not give a damn. You can plug it in Japan, some places that are 110 volt, it still does not give a damn. How the heck that happened? Advancement in silicon technology. Here's the deal. Why the heck we do not have that in electric? We don't, because of stupidity. So flat out, that was the biggest issue. So, and another aspect is our psychological training was not done properly. And yes, we are psychologically trained by marketing department. That's why marketing department gets so much money. Is that we were not trained that EV is a power bank. It's basically like your USB power bank that you carry around. You charge it at night and it allows you to work all day. That's supposed to be how we supposed to use EV. Because in early generations, people had some wisdom that EV is supposed to be only tested by people who have two cars. So one car would be your main car. Another EV would be like for, let's say, your office commute, fixed commute. Like let's say you know your fixed commute from, let's say, home to school. It's a fixed commute. Use electric. Awesome for that. And do not go to a fast charger for that. Just plug it at night. That's how it's supposed to be used. But this whole idea of that charge it at night or charge it when it's static, it was not focused on. Everybody started to focus on obsession with fast charging. We can charge it in 20 minutes. We can charge it in 18 minutes. It's like, no, that's not how it's supposed to happen. You're not supposed to worry about charging. You're supposed to be like, hey, I use it for my normal stuff and plug it at night. The end. Or I use it for my normal stuff. I plug it in the office. I do not worry about it. You're not supposed to be. And this whole this hanger about where it's like, I want this car to have the same range as petrol. No, do not try to do that with Mark 1 product. There is a reason why Mark 1 products requires a certain level of care. And if you directly force it to compete with like something that is in Mike 500, yeah, it's going to be a bad one. So that's what happened. That basically obsession with fast charger literally remove the biggest benefit of electric. People don't even understand how beneficial it is. It's like, I come home, I never have to go to fuel pump. Like you could literally spend months and never ever have to go to a fuel pump. And unless if it's a good, well-built car, you may not even have to worry about maintenance for at least 1 year. So you can imagine that we have been replaced with go to a charging spot. It's like, what's the difference now? So that should not have done for Mark 1. That's detrimental for Mark 1 production. Another aspect is charging standard is not fixed. Like even though we have the technology to do it, like onboard charger can easily work anywhere. By the way, there is only few company that makes onboard charger. And yes, Tesla does not make that. They buy it from some other. So there are 5 or 6 company that makes it. Plug it anywhere. They don't even give a damn. Like you want to plug it in China, it does not give a damn. You want to plug it in Australia, it does not give a damn. So why the heck we cannot standardize on a plug? Now be mindful, people have braids. They did try it. Mark 1 standard was CCS 1. Combined charge standard 1. What does combined mean? Combined means AC part combined with DC fast charging. So you have 3 levels of charging. AC single phase, AC double phase, which you call AC level 2 charging, and then you have DC fast charging. There is no level 3. So that was charge standard 1. That was a rough attempt. It was not very good. But in charge standard 2, again, Mark 2, they improved everything. It was awesome. So this is CCS2. This is the backbone of European Union, and more than enough countries are switching to it, including India. So what they built is like, again, experience. They built it very wisely. So they're like, hey, we got protective earth. Awesome. We have communication pins, 2 communication pins just for the handset. That's awesome. Then we have neutral, GG. Then we have line 1. Here's the single phase. This is what these 3 pins will be connected in your household. You do not have to worry about it. But you can have let's say, heck, I have a 3-phase electricity in my home. So I will be using L1, L2, L3. If you are in America, you will be using L1 and L2. If you are in Europe, L1, L2, L3. Same as like single phase, double phase, triple phase, go YOLO on it. Small plug, no worry about it. AC level 1 and level 2 charging. Now here's the what if you're talking about as 2-wheelers or a light vehicle where you do not want to have like big bulky connectors. So this connectors, especially the DC part is bulky on the back end. So they had brain. They were like, what if we have L1 neutral, protective earth, and again, because the data pins are completely independent, charging data pins, same as like your power delivery, USB-C power delivery. What if we made these two have a relay on the charger end and we use DC? This is DC low. This puppy can pump up to 70 amps at 500 volt, AC or DC, go YOLO on it. There is very few two-wheelers that can actually max DC low of CCS2. And on top of that, they are like, what if you need even more than that, right? So what if you remove the line 1, you remove the line basically neutral, you still have protective, you still have data communication, this will be DC mid, and this puppy can dump up to 140 amps at 500 volts. Calculate that shit. That's way too much power. Like DC low for all two-wheelers is like 90% of the time they are there. If you have a super bike, yeah, DC mid is there. And what about cars? Then they're like, yeah, we do need a bit more oomph. Okay, for DC, they have like DC 500 volts and 200 amps. This is the DC fast charging. So elegantly built. And we could not agree on it. Now, like, oh, humans do not agree on anything. Somehow we agreed on everything when it comes to shipping containers. That's the one thing that works planet-wide. Chargers do work, but they require electrical handshake. That does not happen. This could have solved all the problem. Nobody have, and again, this would have created exponential benefits, meaning all the manufacturers would have figured out how to make it, all the mass production would have happened, cost would have been reduced, everything would be so cheap, effective, efficient. But no. And here's the deal, I really personally, from bottom of my heart, I hate Indian Transportation Department because they're like, we are using this CCS2 for cars, awesome, GG. But we are building our own new BS for two-wheelers. That simply means you have a different petrol pump for two-wheelers and four-wheelers. Why? Have you ever noticed a different fuel spigot for like, oh, this is a truck, there are different fuel spigot? No. Same fuel spigot that works for your scooty, for your car, for your truck, for your bus. Nobody gives a damn about it. This was designed with that. But we're like, what if we created garbage? So far, we still do not have CCS2 as a universal system. Europe has unified it. And yes, Europe did force basically Elon Musk to like, no, just use this. And again, that was another reason why Europe has such a higher success rate compared to all other transition. They realized this puppy is awesome very early on. And they're like, let's do this. India, there was a midpoint where it was so bad. Some places had this, some places had CHAdeMO. CHAdeMO was, if I'm not mistaken, Japanese standard or maybe Chinese. It was different. So one side of our cars had this, other side had CHAdeMO. So we still have not universal, like planet-wide, it's not universal, even though there are only 5 companies that makes charging structures. So that's really hassle. That's a very stupid, bad hassle. And then we have charging stops, because again, we did not focus on household charging, we focused on charging spots, and they were not maintained. They were like, this is one thing that I have to say, Tesla did got this right very early on. It's like they actually spend a lot of money, like actually putting the company in the debt in order to get that right. It's like charging stations, they actually had very high uptime and they've overbuilt it. And they have like if they were expecting 2 cars to maximum use it, they put 4 of them and double redundant everything. They were really good with the charging structure and it did pay off. That's why Tesla has such a good adoption. Other places, again, thankfully they had standardized chargers, so all other companies put into it, but it was another weak link. So all this hassle piled to a scenario where people are not comfortable with EV. Not yet, even though we have been doing this for 20 freaking years. Then we come to the most sad part of it, incompetency, is that technology requires time to mature. Like if you compare Falcon 9 Mark 1 or Block 1, it's good, it was awesome, but it was garbage. Compare that to Block 5, it's like, damn. Block 1, barely 10 tons to low Earth orbit, no reusability. Block 5, I got this fam, 20 tons to low Earth orbit with reusability. So that happens. That's fundamental reality. It's like it takes time to modify. Like right now, you can have USB-C that can transmit data at 5 Gbps. Okay, good. You can scale it up to 40 gigabytes per second while transferring energy with it. How much energy? Yeah, you can start with mild energy of like 20 watt, 30 watt, 40 watt. If you have a chip, 100 watt. What if you have a better chip, extended power range chip, 240 watts, single cable, while transferring 40 Gbps of data. That happens. Again, it will never happen on the Mark 1. It will always take time. So assuming electric vehicles to be like same level of it just works as a petrol system which went through 1 century of research and development, yeah, that was bad. So flat out, this idea, that rush that we had to jumping into full EV, like let's go full EV, was fundamentally stupid. Like it was bad and it was harmful to all of us. Like all of us. There is another aspect of it. Many times people will say, oh, I need an electric car that has range. Here's the deal. No, you don't. You can take Google's data and spread it out. How many people drive how much kilometers per day? The answer is very little. Sometimes some people do drive it, and some people, like let's say you are a taxi driver or something like that, that's a different story. Majority of people, let's say 80% of the people, 90% of the time do not drive very far. They can easily be satisfied with 40 or even 50 kilometers of range. They do not need 500-kilometer range. And because we are trying to compete with basically 100 century research refined product, we are forcing our battery packs to become bigger, which is causing wear and tear on the vehicle structure itself, rubber itself. Tires are also getting expensive, roads are also getting destroyed, and just because we can increase the range. Now here's the deal. What could have been done, right? Like, that's a problem. Everybody knows this. Like, look into the battery bank size of pickup trucks. It's bonkersly huge and does not have the range, because again, battery does not get lighter as you use them up. So you do not travel much further. So fundamentally creates a scenario where it's just not good enough. Not yet. Well, hybrid should have been a solution, because it's a very good bridge technology. It gives you good enough experience where it's like, I got this puppy, this core, this is time tested, 1 century of experience, we got this, I can trust this. Then you build the new puppy. Based on both of them, now you get the benefit done. Now here's the deal. Somehow people jumped the gun, so to say, and they went into parallel hybrids. This is the dumbest idea. If you ever wondered what happened to all those EVs that were like not successful even though they were hybrids, and right now everybody's orgasming, oh, hybrids are making comeback. It's like, why the heck the first generation hybrid did not work, and why the heck second generation is so expensive? Yeah, because both have them smoking weed. They looked into F1 and copied pasted that F1 technology. Now that's supposed to happen. F1 is a training ground. It's a R&D lab for commercial companies. So what they have is what we call kinetic energy recovery system. Somebody thought that's a good system for hybrids. So what you have an engine block. In that same crankshaft, you have a motor generator unit. So when a pilot applies brakes, it becomes a generator, puts load on the rotor that slows down the system and leaches momentum. Forward momentum is leached and charged a battery. Then when straight, you press the accelerator, it takes the energy from the battery, dumps it into the rotor, acting as a motor, increases the RPM. And you are talking about around 50 to 160 horsepower of oomph is added to it. That's kinetic energy recovery system. Now the same philosophy where you have everything connected is in your car system. Chevy Volts and all that, as Honda, Toyota, all of them did that. Consequence, this is stupid way of doing it. This is fundamentally stupid. This is like, it requires a army research level engineering and development to get it done. And F1, again, they throw away engine blocks, so money is no object to them. So fundamentally, this technology was never meant for normal car road. And you want to see how complex these things were? Look into Auto Viewer YouTube channel. He's a professor. He actually does a physical teardown of these vehicles. Look into the teardowns of hybrid cars. You'll be like, how many parts are there? You'll be like, damn. So this hybrid approach where energy can travel from two sources to one link, as in your wheels can get energy while it's getting energy from combustion engine, while it's getting energy from motor. So that sounds good, and it does have that one mind number is bigger than yours, is that if a system is, let's say, 100 horsepower, you can parallel both of them and say my system is 200 horsepower, even though practically it cannot maintain it, but it's like, hey, 200 horsepower, my number is bigger than yours number. So that makes sense in F1, but it's a dumbest idea. So what should have been done? Well, what we have been doing in submarines and combustion engines of diesel locomotive for 1 century. Series hybrid. Now, why series hybrid is better? Here's the deal. Look into engine design, topology of any combustion engine. It's miracle of engineering and is stupidly inefficient. Now, why is that? Well, here's the deal. It has to work with Fast and Furious. Basically, wing, 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 wing. If you are designing a system that works at so many RPMs, it will be inefficient. Go to any engineers like, bro, this is engine block. Design this puppy to be as thermodynamically efficient as possible, like as in the megajoule in the fuel, I want kilowatt in the generator. They can give you a system that is very efficient, bonkersly efficient. But we cannot do that if you are changing the RPM and changing the torque. We do our best. We have variable valve timing, variable crank systems, way too many magic lumbo jumbo. And consequence, it does work. Consequence is inefficiency, and price is also higher. So when you are building a series, because you are not physically connected, you do not need to worry about Fast and Furious effect. You are saying, hey, give me an engine block that is as thermodynamically efficient as possible. So as much fuel it consumes, it gives the most megajoules out of it. Then you run a generator, because the benefit is now you can also torque lock it. You don't have to worry about the RPM, also have to worry about torque loading. So you don't want both of them to be optimum spot. That gives you the most efficiency. So once you have the most efficiency, then the energy goes into the inverter and charges the battery. Now what happens if person presses the accelerator? They want more oomph. Here's the deal. Energy comes from the motor, and then it's like, hey, I'm actually need more energy than what the generator is providing. No problem. It, for short duration, basically while you're accelerating, it drains the battery. Now, when you apply brakes, again, it acts as a regen. The basically battery becomes a buffer. This is far more efficient, far more logical. We have been using this. It works. All locomotives works on this. No clutch, much more simpler, and it gives you simple efficiencies. Like 1 century of research and development, let's refine it to the nth degree. And now we only focus on making a motor system and smaller battery. You do not need like 33 kilowatt hour battery capacity. You can be fine with 10 kilowatt hour. And everybody is like, I need to travel 300 kilometers. No problem, sir. Put fuel, go YOLO. It's like, I only travel 10 kilometers per day, which again is still a lot. Let's say 20 kilometers. 10 kilowatt, 20 kilowatt, actually it will be lighter. It's much easier. And you don't have a transmission box, much lighter, much more simple. Everything is simple. Now, when I'm saying this, it does not mean I'm the only one. Again, I specified it's a known technology. We have been there, done this, got this. And to achieve this, this was so easy to do. This guy, just one guy, he was like, swooped up into Elon Musk brain damage. Everybody does. I was at one point was Elon Musk's fan. And he put money, like physical money, hard-earned money into a Tesla semi-electric system. He put the money down. Okay, awesome, GG. He had to wait, and then he's still waiting. And then he had to wait, and then he's waiting. And then he started to actually think, because he's an actual truck driver. He was like, you know what, this does not make sense. This does not make sense. He's like, and then he was voicing his opinion. People said, oh, you should open a truck company. He's like, you know what, it's taking so long for Elon Musk to deliver. I will. He opened the company, Edison Motors. He built a truck. Topsy, got it certified by Canadian system. Be mindful, this is the only company in last 30 years to do so. They did it. It's like a trucker built it. Why he could build it while Tesla engineers have been grinding for years? Simple. It's KISS. Keep it simple, silly. He's not trying to do brain damage things where it's like, what if we have battery charger that is 5 megawatts? What if you don't? What if you put as minimum as possible, and then you just have a generator, motor generator unit, and you do not have to worry about the efficiency of the system. Why? It's the RPM locked as in like it goes to the RPM that it needs to, and then it stays there. And torque, it goes to the torque that it needs to, and then stays there. Everything is efficient. So compare this puppy to any other normal locomotive system. This will beat all other systems, even though it's like, hey, it has conversion, because it's working the engine at that 35% efficiency bracket compared to 22-ish that you get in real world of normal other systems. So this actually gives you more mileage. And because he was like actually practicing this puppy on a logging industry where it's like travel empty, cut woods, collect wood, bring it down heavy, he was getting 60% more mileage. Why? Again, regenerative braking. That's how easy it was. Like, and by the way, he's still waiting for his Tesla. He has not arrived yet, Tesla semi. So that's how I said it's incompetency, putting F1 technology into a place where it does not belong. Series hybrid solves all the problem. Smaller battery bank, lighter vehicle, and yes, it does not, my number is bigger than yours. It does not have that, but it's logical, practical, it works. And again, this will actually create less friction with people who want oil companies to say, hey, we're still consuming oil. And again, this also has the benefit. Let's say in future, you create a fuel cell. There are some people who are working on fuel cell that can consume hydrocarbon, and it will be smaller, more energy efficient. 45% efficiency is theoretically possible. Swap that part. Generator and engine part, swap that with the fuel cell, go YOLO on it. So that's the whole point. It could have been so awesome. An awesome bridge technology where you can let the R&D part happen. But no, we're going to use F1 because we have to throw away engine blocks. So what can we expect in the future? Well, here's the deal. The reality is, it has come to the table, is that younger generations are fundamentally more poor than their parents globally, including me also, unfortunately. And yes, it is worldwide. Yes, it's also happening in China. China is so bad right now. They have what I call let it rot movement. Like, people are genuinely giving up, and it is brutally bad. How do I know that it is bad? It's not propaganda and all that. Yes, Xi Jinping is directly talking about this. That's how I know it's bad. So yeah, it's bad. And Europe, let's not even talk about housing crisis and inflation. Let's not even go to America's student loan crisis, or the rent is too goddamn high. The reality, it's bad. Everywhere it's getting out of hand. So fundamentally, we have crossed all the data points point to this absolute reality where parents were richer, kids are poorer. Of course, there will be that 1% that has like everything sorted, but do not focus on 1%, do focus on 99%. Yeah, that's bad. Now, what does that mean for the companies? Well, market no longer have steady state of new customers, meaning the kids who are reaching the driving age, they are not buying cars. They are not even planning for it. Then they, like, even in their imagination, the car is not a thing that they are planning. Be it America, be it India, they are not even planning for that. Half of the kids are like worried about their education. Other half is worried about staying there. So they are not in a position. So who is buying cars? Well, people who are already well off, so they are buying their second car, third car, fourth car, or if they are billionaire, 50th car. Yes, I'm not even joking. And yes, there are more than enough Indians who are that kind of rich. So as long as they are alive for short duration, car market is stable. But once they start to pop off, it will randomly hit like a ton of brick, where it's like, wait a minute, nobody else is buying a new cars. So that is a very bad situation for companies, like very bad. People who are struggling with their basically housing crisis, yeah, and they are working with the health crisis. I'm not even going to go there, health prices. So people who are worried with that, they are not worried about cars. They are like, that's so far ahead of them that they do not have to worry about it. And again, government used to allow second hand, third hand. Now they are forcing pollution norms as a like a clean the market kind of scenario, where they're like, okay, if this car is made 15 years ago, you have to scrap it. It cannot be reused. That's a very bad thing to do, but can't do much about it. And all the lie that has been told, again, that second hand cars had to be discarded because it's 15 years old and pollution norm, like, it's working. Let it use. Again, instead of creating new carbon footprint, it's working, let it run its course, and when it dies, let it pass. Let's not force it. But what if we force it? So all these things, that poor charger implementation, incompetency of not using normal series hybrid and trying to do this brain damage thing of parallel hybrid things, all these things erodes faith. And yeah, it's super easy. There is no maintenance unless something bad happens, and then you're like, wait a minute, $50,000 I have to spend it to replace the battery. Yeah, at that point, people are like, what was the point? And it is affecting people. Like, yes, deal, not everybody is rich. Let that be very clear. Not everybody is rich. I'm like, duh, but that's the reality. Not everybody is rich enough where they're like, oh, I can spend 70% of the car's of money directly on the just a minor inconvenience. Yeah, does not happen. So all this thing erodes faith. And this forceful removal of basically second-hand cars, third-hand cars from the market, it means sooner or later EV will take over. Let that be very clear. I'm not in any position where I'm saying, oh, that will not happen. Of course, it will happen. It's just like it should have happened gradually, properly, on its own, without requiring intensives and forceful evacuation. It should have happened automatically. Why didn't? This was the video of that. So it will happen, but it will be far more forceful now. And it would be very painful for people, because again, once they actually realize, wait a minute, I'm buying a car that I cannot even theoretically hope to resell, because again, once you do that and compare the inflation prices, expected battery prices, you're like, yeah, no. Yeah, that would be too painful for most. Another aspect is planned obsolescence, and Tesla is really bad on this. It's like, it's horrible how much vehicle they just throw away because, oh, this thing broke, and we are like, what if we F the customer? It's like, and again, once Tesla does it and everybody is like, oh, Tesla, 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 other companies started to do it. So car went from lasting for 40 years. Yes, people have used that, to 20 years, to 10 years. Now I'm actually worried about my new car, that like my new car is like 3 years old. So I'm actually worried about that. Like, will it actually last? So planned obsolescence on cars is not good, flat out not good. Not enough people are rich enough anymore. And it's flat out not viable for youngster. If people are worried about their schools, their education, their health, their homes, ain't nobody got time for cars. Flat out, ain't nobody got time for that. So what will happen? Car as a service will become a thing. Now here's the deal. Wouldn't that be awesome for car manufacturers? No, because those car manufacturers, they will buy industrial grade car. What does that mean? That simply means a car that has more reinforcements. It's like built more oomph, more oomph. Now here's the deal. You may pay attention to the people that are milking the planned obsolescence. They are very rich companies, like $2 trillion company. Apple, that is a company that is like 150 years old, if I'm not mistaken, give or take, somewhere that time. German engineering companies, they are making awesome machines, industrial tools. They are awesome. They're still here. They're still working. Everything is fine. Everything is dandy, but they're not very rich. Why? It's not planned obsolescence. Once you make an industrial, it's super expensive, but it's like sell once and do not worry about it. It's like mechanics have the saying, like, buy cheap, buy twice, or buy once. So in that environment, car companies will not be printing money. So they really have to apply disc brake on a planned obsolescence thing. Because again, once enough people start to get burnt, they will be like, bro, I'm just gonna Uber it. And again, youngsters are doing it right now in big cities, in India, in America, in Australia. They are doing it because it's like not everybody has the money. It's like, oh, just work hard enough. It's like, have you seen inflation? Have you seen the price of food? Food is getting expensive in India. I do not even want to see what is the food price in America. So flat out, future is very shaky for car industry. Far more. They're like, they will one day they'll wake up. It's like, hey, we have been noticing a downtrend in the market for last 10 years. It's like, what's happening? And they're like, oh yeah, sorry, it will never go back up. There is not enough rich people anymore. And 1%er, they do get bored after their 100th car. So yeah. So this was my presentation on why EV adoption was not as quick or as efficient or smooth as should have been. Hopefully you guys have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.